guys, welcome back to Wong Chemistry channel. For this video, it's the part 3 video of your 5.2 liquids. And in this video, we are going to discuss two things, which is Vapour pressure and also boiling point. We are also going to discuss the relationship between the Vapour pressure and boiling point and also the factor affecting both of them. Alright, so let's start with Vapour pressure. What is actually Vapour pressure? Vapour pressure is the pressure produced or exerted by the vapor molecule above the surface of the liquid. Don't worry if you don't understand, I'm going to explain to you in details what is actually Vapour pressure. So the first condition that you must have before we discuss about Vapour pressure is a closed system, where we can only discuss about Vapour pressure in a closed system. Alright? Next, we know that your vapor molecule will move continuously and randomly. All the vapor molecule will move continuously and randomly. So all this vapor molecule that you have above your liquid down here will be moving continuously and randomly in any direction. Okay? And when they move continuously and randomly, what will happen? Collision. Collision will occur between the molecules or between the molecules and also the wall of the container. So there's two types of collision. One is between the vapor molecule. Second is between the vapor molecule and the wall of your container. In the other words, all this vapor will be colliding with each other, or the vapor will be colliding with the wall of the container. Okay? And the most important thing, what happened during the collision? Every single collision that happened will produce pressure, and the pressure that produced by the vapor in the closed system is what we call Vapour pressure. Can you see that? So you will have vapor above your liquid. All this is your vapor. Knowing that your vapor will move continuously and randomly, so they will collide with each other or the wall of the container. And during the collision, pressure produced. So the pressure produced is what we call Vapour pressure. The pressure that produced by the vapor molecule in a closed system above the surface of the liquid. That's it about Vapour pressure. So there are two factors that will be affecting your Vapour pressure. The first one is temperature. The second is your intermolecular force of attraction between your liquid molecules. Okay? Let's see. So the first factor that will be affecting your Vapour pressure is your temperature. So let's see what happens when the temperature of the liquid increases. We know that whenever we talk about temperature, we always talk about kinetic energy. So when the temperature increases, the average kinetic energy of the liquid molecule increases. So the liquid molecule that's sitting in the liquid, obviously, will have a higher kinetic energy when the temperature increases. Alright, so the kinetic energy of the liquid molecule increases because my temperature increases. Agree? And since the average kinetic energy of the liquid molecule increases, therefore, there will be more liquid molecules have enough kinetic energy to overcome the force of attraction. So, there will be a lot of molecules that will be able to overcome this force of attraction. And what happens when they can overcome the force of attraction? You will then have more liquid molecules that are able to escape and become vapor. Once the kinetic energy is strong enough to overcome the force of attraction, your liquid molecule will escape and become vapor. Agree? Therefore, your Vapour pressure will be higher because you have more vapor form. You will have a lot of vapor on top of the liquid. So when the vapor molecule increase, so what happened? You will have more collision. And do you remember what will be produced during the collision? You will then produce more pressure. When you produce more pressure, what is that pressure named? That pressure is your Vapour pressure. So you will have a higher Vapour pressure. In the other words, your Vapour pressure will be higher when the temperature is higher. So your Vapour pressure is directly proportional with the temperature. Okay. Next, the second factor and also the last factor affecting your vapor pressure is your intermolecular force of attraction. So, let's see how this factor will be affecting your vapor pressure. When the intermolecular force of attraction in the liquid molecule are stronger, it means in my liquid over here, between the liquid molecules, alright, between all these liquid molecule, the intermolecular force of attraction between this liquid molecule are extremely strong. So what happens when the intermolecular force of attraction between the liquid molecule are very strong? The liquid molecule then require a higher kinetic energy to overcome the strong force of attraction. Agree? So if I want this liquid molecule change to become vapor, what do I need to do? I need to overcome this strong force of attraction. And to overcome this strong force of attraction, I require a higher kinetic energy, right? But not everyone having the high kinetic energy. So you will have a fewer liquid molecule that have enough kinetic energy to overcome the strong force of attraction. Not everybody will have that high kinetic energy to overcome the force of attraction. So when you're not able to overcome the force of attraction, you will then stay as a liquid because you cannot break yourself from the force of attraction. Okay? So when I need a high kinetic energy, not everybody will have that high kinetic energy. So will there be a lot of vapor produced? No. There will be less or there will be a fewer liquid molecule able to escape and become vapor. So your vapor molecule over here become lower. The vapor molecule that you produce is much lower because the liquid force of attraction is very strong. Not every liquid molecule can break the strong forces. So most of them will remain as a liquid. Therefore, your vapor molecule decrease. And guys, when the vapor molecule decrease, the collision will also decrease. Agree? Because you have less vapor over there. So the number of collision also decrease. And when the number of collision decrease, guys, what happened to the vapor pressure? The vapor pressure will also decrease. See that? Because you have less number of vapor. Okay? So as a conclusion, when your force of attraction is very strong, okay, when your force of attraction is very high, your vapor pressure will be very low because it's very hard to overcome the force of attraction and therefore it's very hard to escape to become vapor. So most of them will remain as a liquid. Number of vapor molecule decrease, less collision, less pressure. Okay? So your intermolecular force of attraction and your vapor pressure are inversely proportional. Alright? And that's it about vapor pressure. So that is everything about vapor pressure that you need to know. And make sure you remember this because we are still going to discuss this at the end of this video. Okay? Next, let's go into boiling point. What is actually boiling point? Boiling point is the temperature which the liquid boil and the vapor pressure of the liquid equals to the pressure of the atmospheric. Okay? So your boiling point is when your vapor pressure is equals to the atmospheric pressure. That temperature is what we call boiling point. So let's see over here. That is my atmospheric pressure. Okay, we have our atmospheric pressure over here. That is my liquid. Okay, and in the liquid, we have a lot of molecules as always. Okay, what will happen is some of the molecule will have enough kinetic energy to overcome this force of attraction. And when they're able to overcome, they will then become vapor, right? And this vapor, the vapor over here, will produce vapor pressure. Remember that? Okay, so you have a lot of vapor in here and the collision between the vapor and the collision between the vapor and the wall of the container will produce vapor pressure because you will have more and more liquid particles that can overcome the force of attraction and become vapor. So when the vapor increase, your vapor pressure increase. And up to one moment where at a very specific temperature, your vapor pressure that produce on top of the surface, or the vapor pressure over here, equals to the atmospheric pressure that you have outside the container. So when the vapor pressure inside the container is equals to the atmospheric pressure outside of the container, that temperature is what we call boiling point. Alright? So boiling point is actually a temperature where the vapor pressure is equals to the atmospheric pressure. Okay? That is the time your water start to boil, your liquid start to boil. Alright? Alright, let's look a bit more about boiling process. Okay? The changes that occur for the boiling process happen to the surface and also the inner part of the liquid. Have you ever boiled water and the water will only boil on the surface? No. When you boil water, it will look something like this. Okay? Where you can see the bubble is boiling up from the bottom until the surface of the water in the inner part of the water. Right? Because when a boiling process is happening, it will not happen only to the surface of the liquid. That is the difference between vaporization. Okay? Boiling process happens to the entire liquid, from the bottom to the inner part to the surface of the liquid. Remember that. Okay? Next, the temperature of the boiling point will remain constant even though the heat will be continuous supply. If you are boiling a water and knowing that the water that you have over here, the boiling point is 100 degrees Celsius. So when you have the pot of water and it already boiling, but you're still on, alright, your stove is still on, which means the heat is still supplying. But if you put in your thermometer, the thermometer will still give you the reading of 100 degrees Celsius. So the temperature of the boiling point will not change even though the heat is continuous supply. Okay? Next, the boiling point process will occur at a very specific temperature and pressure. So every single compound that you have will have their very own boiling point. Like water is 100 degrees Celsius. Okay? Ethanol, methanol, all the alcohol will have a different boiling point. Alright? Their very own and very specific temperature. And also, we will have a very specific pressure. Because the surrounding pressure, the atmospheric pressure, will be affecting your boiling point. Think about boiling water at home and also boiling water on top of Mount Everest. The boiling point of the same water will be different due to the different pressure. We will look into that later. Alright? Next, let's look at the factors affecting your boiling point. There are 3 factors. The first one, the purity, atmospheric pressure, and also, last but not least, intermolecular force of attraction. So let's jump straight into the first one. Purity. So purity means pure. How pure is your water or how pure is your liquid? So having impurities will change the boiling point. And how can the impurities change the boiling point? If you have more impurities, it will increase the boiling point. The higher impurities that you have in your liquid, the boiling point of the liquid will be much higher than the pure liquid. Okay? So, impure will have a high boiling point, while your pure will have a lower boiling point. Okay? Always remember that impurities will increase the boiling point. And it's proven by looking at this table. When you have the amount of salt is added into your pure water, you can see over here when it's a 0 gram of salt, means that it's my pure water. And the boiling point is 100 degrees Celsius, as everybody knows. But when you put in 2 grams of your impurities, your salt, you realize that the boiling point increases. From 100, you're going up to 103.1 degrees Celsius. And what happens when the amount of salt increases? When you have all the way to 10 grams of your impurities, you realize that your boiling point from 100 degrees Celsius go all the way up to 109.5 degrees Celsius. I hope you can see that your boiling point will actually increase when your impure or your impurities increase. Okay? Simple. Next, atmospheric pressure. So how atmospheric pressure will be changing your boiling point? Simple. When the atmospheric pressure is higher, just imagine your atmospheric pressure over here is much higher. So you will have a much higher pressure pressing on your container. Agree? So you will then need a higher vapor pressure, because we know that in boiling point, your vapor pressure will be equals to your atmospheric pressure. Then only we say we reach the boiling point. So when the atmospheric pressure is higher, that means your vapor pressure in here also must be higher, right? So you need more liquid molecule to change to vapor. From the liquid, alright, that is attracted with force of attraction, you need more molecule that can overcome the force of attraction and change into vapor. Then only the vapor pressure will increase, right? So the average kinetic energy of the liquid molecule must be higher, because you want to overcome this force of attraction. You want to overcome this force of attraction so that the liquid can escape and become your vapor, right? So how can we do that? You need a higher kinetic energy. Alright, every liquid molecule must have a higher kinetic energy. Then you can overcome this force of attraction. So when you need a higher average kinetic energy, it means you need a higher temperature, because temperature is required to increase the average kinetic energy. And when you need a higher temperature, guys, higher temperature stands for what? Higher boiling point. When you need a lot of energy, you need to keep boiling, so your boiling point will increase. So in the other words, your boiling point will increase when your atmospheric pressure increase. Okay? They are directly proportional. When your atmospheric pressure increase, the atmosphere pressure is very strong. So you also need to increase the vapor pressure so that the vapor pressure and atmospheric pressure can be the same and you achieve boiling point. So how do we achieve more vapor pressure? You need more liquid molecule change to vapor. So to ensure more liquid molecule can change to vapor, you need a higher kinetic energy. And higher kinetic energy coming from higher temperature. That's why you will have a higher boiling point, because it needs longer time to reach the higher temperature so that you will reach your boiling point. See that? That is how your atmospheric pressure is changing the boiling point. So let's look at this example over here. I have our Mount Everest. Mount Everest is about 8,850 meters above the sea level. So that is our sea level. Okay? So let's say you're boiling your water over here. You have your fire. Alright, that is your source of fire. And then you have your beaker that having water. So if you're boiling your water over here, okay, what will happen? At the sea level, where the pressure is 1 atm. So that is the sea level, okay, where the atmospheric pressure over here is only 1 atm. Okay, your water will boil at 100 degrees Celsius. So your boiling point at sea level for a pure water will be 100 degrees Celsius. But what happens when you move all the way up to your Mount Everest? Let's say you're climbing the Mount Everest and you reach the Mount Everest top. So sitting 8,850 meters above the sea level, what happened to the pressure? The pressure of the Mount Everest peak is about 0.3 atm. Can you see that your pressure decreased? So when your pressure decreased, what happened? In the Mount Everest, your beaker that having water over here, and the atmospheric pressure right now is lower. When the atmospheric pressure is lower, less vapor is needed. Agree? When less vapor is needed, then your boiling point will also decrease. Your boiling point from 100 degrees Celsius on the sea level going up to your Mount Everest, your boiling point left with 70 degrees Celsius due to the low atmospheric pressure. The atmospheric pressure on top of Mount Everest is only 0.3 atm. So your water will definitely boil faster on top of your Mount Everest because of the low atmospheric pressure. So it's very easy for us to achieve that your vapor pressure equals to your atmospheric pressure. Because your atmospheric pressure is very low, therefore your vapor pressure required is also very low. So it's very easy to achieve because you only need that little of vapor pressure. Then you can reach your boiling point. See that? See the difference? The same thing, but how your atmospheric pressure is changing your boiling point. Alright? Last but not least, the last factor that will be affecting your boiling point is your intermolecular force of attraction. So let's see how this factor will be affecting your boiling point. When the intermolecular force of attraction is stronger in the liquid, so I have my liquid over here as always, you have your liquid molecules, and knowing that your liquid molecule right now is having a very strong intermolecular force of attraction. So when this is extremely strong, what will happen? The vapor pressure will be extremely low because less vapor is produced. Very simple. When the liquid molecule right now is holding very, very strong, okay, you're having a stronger force of attraction. When they're holding very strong, it's very hard for the molecule to overcome the strong forces. So when it's very hard to overcome the strong forces, it's very hard to escape and become vapor. So when you have less vapor over here, your vapor pressure will definitely decrease. Okay? But your atmospheric pressure that pressing this down is still that high, remain the same. So when your atmospheric pressure is the same, but your liquid having a stronger force of attraction. So what do we need to do? We need more energy for the liquid molecule to increase the kinetic energy. So when you are having more energy, means that your liquid molecule having a higher kinetic energy. When you have a higher kinetic energy, you can overcome the strong force of attraction. When you can overcome the force of attraction, you then can release and become vapor, right? But more energy means what? More energy means your liquid need to boil longer. You need to leave it on the heat supply longer. Therefore, you will have a higher boiling point. So, the stronger the force of attraction in the liquid molecule, the higher the boiling point will be. Simple. Because you need higher average kinetic energy so that you can overcome the force of attraction and escape to become vapor. Okay? So that is how your intermolecular force of attraction is affecting your boiling point. The stronger the forces, the higher the boiling point. Simple. So after we have learned everything about your vapor pressure and boiling point, so the question would be, what would be the relationship between your intermolecular force of attraction, your vapor pressure, and also your boiling point? How do we relate them together? Simple. Let's say that your intermolecular force of attraction in liquid right now is extremely strong. So when the force of attraction in the liquid is extremely strong, okay, this one is extremely strong, what will happen? Your vapor pressure will decrease. Why your vapor pressure will decrease? Simple. Your force of attraction right now is extremely strong. So there will be less molecule that can escape and become vapor. So when less molecule can escape and become vapor, means that you will have less vapor. Less vapor, less collision. Less collision means vapor pressure decrease. Okay? And when vapor pressure decrease, but the atmospheric pressure remain the same. So, you will still having the same atmospheric pressure. Your atmospheric pressure that pushing down is still the same. But your vapor pressure over here decrease right now. So what do we need to do? You will then need to leave it on the fire source longer. So you will have your fire source over here burning. Alright, you need to leave it longer on the fire source so that you will have more molecule from the liquid change become vapor. Agree? Therefore, your boiling point increase. So, the relationship between them, look at it. The intermolecular force of attraction strong means that less vapor, less collision, the vapor pressure decrease. Inversely proportional. Okay? And because the vapor pressure decrease but you still want to achieve your boiling point, you still need a higher vapor pressure. So you need more molecule from the liquid can escape and become vapor. So how do we do that? We need a higher kinetic energy. And how do we have a higher kinetic energy? Simple. We boil it longer. So you will have a higher boiling point. Simple. And that is the relationship between your vapor pressure and your boiling point. If you have any question regarding your vapor pressure and boiling point, drop it in the comment below and I'll get back to you as soon as I can. I really hope this video able to help you to understand the relationship between the vapor pressure and the boiling point, and of course the factor affecting. Alright, thank you for watching and make sure you like the video, subscribe to my channel, and I'll see you again in the next video.
TunePocket.com